Hello, champions. Okay, so this is chapter 1, Ratio and Proportion, Indices and Logarithms, Unit 3, Indices. Okay, I hope I'm audible. Let's start with this unit. Learning objectives. After reading this unit, a student will learn a meaning of indices and their applications. So let me tell you what are indices before we read it in the text. So for example, we have 2 raised to 4. So we call this 2 as base and 4 as power or index. This is known as index or indices. Okay, so we are going to study about what they um, give us, how do they give us more ease in our calculations, what are their applications, what are their laws. So laws of indices which facilitates their easy applications. So these laws are very, very important. Well, you will have to understand this not just for this exam, but because when you move ahead with the next level, the final level, and in your real practical world using this degree or in anywhere, you will have to know that maths has some basic rules and logics, something which you have to know. You cannot move ahead without these laws and some rules, because it will come in your practical life as well. Okay, let's just directly get into the text. Unit overview. Overview of indices. So meaning of indices and laws of indices. So indices, I've told you the power. This is known as or index or power. This is known as base. Okay, and there are four laws actually, four laws, and still many simplified maybe rules you can say that we use. So there are four laws. Law 4. Okay, we are going to study ahead. You can write it over here once we study. Let's get into it. Indices. We are aware of certain operations of addition and multiplication, and now we take up certain higher order operations with powers and roots under the respective heads of indices. Let's focus this sentence. Okay, so powers 2 raised to 4 is a fourth power for the base 2. What is roots? Like for example, when we write square root of 4, how will we write this 4 as in terms of power? So we will write it as 4 power half. This half is denoted as root 4, which we know the answer is 2, right? So for example, if we write cube root, cube root, so suppose cube, let's start with cube. Let's start with 2 cube. So 2 cube is 2 into 2 into 2, right? 2 into 2 into 2, which is equals to 8, correct? So cube root of 8 is 2. We can read this very well now. So how will we write in a form, right? Index form. So suppose I have to write cube root of 8. So it is, I will write cube root of 8 as 2, and in the index form I'm going to write it as 8 power 1 third. The same way as I have written 4 power 1 half for the square root. If I have written 2 power 4, okay, which is 16. So 16 power 1 fourth is equals to 2. So that is fourth root of 16. Okay, we are going to study further. Let's read the text. So now we take up certain higher order operations with powers and roots under the respective heads of indices. Okay. So power is index or indices. Roots, okay. So before we'll get into the text again, there are some things I want you to revise with me. Okay. Because these are very important and it will help you solve the questions in the exam very easily. Let's revise. Now you understood 2 square is 4. So let us revise squares from 1 to 10. Sorry, 1 to 20. We are going to revise squares, and I want you all to write it in your book. Some things that I'm going to revise it with you so that it will become very easy for you to solve this unit. Okay, so let's write squares from of 1 to 20 numbers. So 1 square 1, right? 2 square 4. I want you all to write it in the comment section. 3 square 9. 4 square 16. 5 square 25. 6 square 36. 7 square 49. 8 square 64. 9 square 81. 10 square 100. Okay. Now 11 square 121. 12 square 144. 13 square 169. 14 square 196. 15 square 225. 16 square 256. 17 square 289. 18 square 324. 19 square 361. 20 square 400. Okay, so what about cubes? So I hope you remember these squares from 1 to 20 by heart so that it will be very easy for you. If you spot any number like 324, you should be able to tell that it is the square of 18. These numbers, if you see in the problems, you have to be very quick by clicking in your mind. Learning squares and cubes will improve your common sense as well. Okay, cubes. 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125, 6 cube 216, 7 cube 343, 8 cube 512, 9 cube 729, and 10 cube 1000. So it is very important that you at least know cubes of 1 to 10 numbers. Okay, I hope, because for example, if the question gives 343 power 1 third, you should be able to do this calculation without the calculation trick that I'm going to share and show you how to calculate if it is some another nth power which you don't already know. But if you know, if this number comes in the exam, you should be able to verify it very quickly that it is the cube root of 7. Okay, so you understood that in a square. Okay, so my question, please write your answer in the comment section. In a square, what is the power of the nth number? It is 2 because it's a square. Since we write the power or index as 2 and base as n. And in a cube, what is the power of the nth number? It is 3. Okay, good. So let's revise some equations that we might have already studied in school times, but even if you have not, I would want you all to remember these formulas, because these formulas are going to come in your questions, okay, some or the other way. So the long form of these formulas, you will have to, you know, improve your common sense so that you can click the answers easily. Okay, let's see what I'm talking about. So what is a plus b whole square? It is a square plus 2ab plus b square. Correct. So next, what is a minus b whole square? It is a square minus 2ab plus b square. Next, a plus b into a minus b. It is a square minus b square. Then what is a plus b whole cube? It is a cube plus 3a square b plus 3ab square plus b cube. You can again expand this as a cube plus b cube plus 3ab bracket a plus b. Similarly, what is a minus b whole cube? It is a cube minus 3a square b plus 3ab square minus b cube. Expand this one as well. A cube minus b cube minus 3ab bracket a minus b. Next formula, a cube minus b cube. A cube minus b cube is equals to a minus b and a square plus ab plus b square. Okay. And what about a cube plus b cube? It is a plus b into a square minus ab plus b square. Okay. So there are two more special formulas that I'm going to share, since these formulas are also used, very much in our problems and exams. So let us write it in the simplified form, and I'm going to teach you. Given, you can write the heading as special formula. Okay. So given x is equals to a raised to 1 by 3, that is cube root of a, minus a raised to minus 1 by 3. I'm going to teach you what does minus 1 by 3 means. Let me still tell you right now. It means 1 divided by a raised to 1 by 3. Okay, so a minus 1/3 is equals to 1 divided by a raised to 1/3. So if this is already given, this equation is already given, and you are asked what is x cube plus 3x. Okay, this question, this equation is often asked. So the answer is a minus 1 divided by a. Okay, let's not get into the proof of it formula. Let's just write this in your, just write it in your book. The next formula is again given, x is equals to a raised to 1/3 plus a raised to minus 1/3 minus 1/3. Then x cube minus 3x is equals to a plus 1 by a. Okay, I hope you understood this. Okay, so before we read further, let me directly get into it. Right. So we know that the result of a repeated addition can be held by multiplication. Like in this example, you are adding 4 5 times, right? So how are you going to write it as 5 into 4, which is 20. So we have seen addition in form of multiplication. If I write it in with the help of variables, how I am going to write, if a is added 5 times, I am going to write 5 into a, 5a. Now, what about if 4 is multiplied 5 times? How are we going to write it as? 4 raised to 5. Similarly, a is multiplied 5 times. We are going to write it as a raised to 5. It may be noticed that in first case, 4 is multiplied 5 times, and in the second case, a is multiplied 5 times. In all such cases, a factor which multiplies is called the base. This is called as base, right? And the number of times it is multiplied is called as power or index. Correct? Therefore, 4 and a are the bases and 5 is the index for both. Any base, okay, important, very, very important. Any base raised to the power 0 is defined to be 1. So anything raised to 0 is equals to 1. Okay. X raised to 0 is equals to 1, a raised to 0 is equals to 1, n raised to 0 is equals to 1. Okay, anything raised to 0 is equals to 1. Okay, and we assume that a or x or n is a non-zero number. We also define, okay, so I have already told you how to write nth root, right? So a raised to n, we know this, right? So if a raised to n, so suppose this is square, right? So we write it as a square, and a nth root we write it as a power 1 by n. So if here they should have written n. Okay, so if n is a positive integer and a is a real number, okay. So before we move ahead again, some things I want you to remember. Now, power and index we understood. So let's see. Let's remember the power, all the 10 powers of base 2. Okay. So write your answers in the comment. 2 raised to 0 is 1 or 2? No, it is 1, right? 2 raised to 0, 2 power 0, 1, 2 power 2 power 1. 2 power 1 is 2, 2 power 2 4, 2 cube 8, 2 power 4 16, 2 power 5 32, 2 power 6 64, 2 power 7 128, 2 power 8 256, 2 power 9 512, 2 power 10 1024, and 2 power 11 2048. So if you remember, there is a game called as 2048. So it is 2 power 11. Okay. So a raised to 1 by n is what? It is nth root of a, right? A raised to 1 by n is equals to nth root of a. So if n is a positive integer and a is a real number, we will see how to tackle n as a negative integer further as one of the laws of indices. Okay, so it's like we'll see key how I have told you, right? Okay, just a minute. So a power 1 by n is nth root, correct? And a power minus 1 by n is 1 divided by nth root of a. Okay, did you understand? Okay, so let me ask you, what is 11th root of 2048? 2. And 10th root of 1024? 2. And third root of 125? 5. Okay. Okay. So let's see this equation. A raised to n is equals to a power n is equals to multiplying a n times. Okay. So here n is a power of a whose base is n and index is whose base is a, sorry, and index is n. For example, 3 multiplied 4 times. 3 is base and 4 is index. Now you are very well familiar with what is base and what is power. Let's see law number 1. What does this law says? A power m into a power n is equals to a power m plus n. Okay, let me prove this first. So let's take this first term. What does a power m means? Multiplying a m times, right? And what does a power n means? Multiplying a n times. Okay, and if we are multiplying both of these, so that means here multiplying m times and again multiplying n times, that means there are total m plus n times, right? Which is the proof that it is equals to a power m plus n. Let me show you with an example. For example, 2 power 3 into 2 power 6. So let's expand this. 2 power 3 means 2 multiplied 3 times. Then you have a multiplication. 2 power 6 means 2 multiplied more 6 times. 4, 5 and 6. So how many times it is multiplied? 2 power 9 times, which is equals to 6 plus 3. Okay, which is 512. Okay, now if you decode this or maybe question that is there any rule or law for a power m added to a power n. So since we are multiplying here, correct? So is there any rule for a power m plus a power n? No, there is no rule because here we are going to multiply a m times and then you're going to add a n times. So there is no such simplified way to put it in a law. So it is not applicable for addition between these two uh, base and indexes. Only it is for multiplication. Okay. So law 1 is applicable only when a power m is a power m is multiplied with a power n. Now we extend this logic to negative integers. So you have seen this. We have proved this. Okay. A raised to m plus n. Okay. Now here m and n are positive integers. It is already assumed. We'll see if it is it applicable for negative integers as well or whether why it, if at all it is not applicable. Let's see. Now we extend this logic to negative integers and fractions. Okay. And this negative integers will give you more laws. First, okay. So let me just tell you. Okay. So what about a power m into a power minus n? How will we simplify it? A power m into 1 divided by a power n. So what does this mean? A power m divided by a power n. Now what? What is our simplification? A power m and a power n. So let's see with an example. So 2 power 6 divided by 2 power or maybe 2 power 2. Okay, so 2 multiplied 6 times, 5 and 6, and 2 multiplied 2 times. So you get 2 power 4, which is actually 2 power 6 minus 2. So what do you actually get? You get a power m into a power minus n is equals to a power m minus n. It is simplified form of law 1, but this becomes law 2. Okay, and we write law 2 as a power m divided by a power n is a power m minus n. Okay, this is law number 2. Let's stick with these two laws, a power m plus n and a power m minus n. And let's take some examples and try it out. Okay, whether these law work or not. Okay, so give me the answer for example, a power, hold on. Okay, so what if I substitute, okay, n, m equals to n. Okay, so what do I get? A power n minus n. And what do I get? A power 0, and anything raised to 0 is 1. Okay, next, a power n into a power minus n. What about this? Again, you get it as a power n minus n, which is equals to 0. Okay, next example. Let's take some numbers. 2 power minus 5 into 2 power minus 1 by 5. Okay, so let us first simplify whatever we know. Okay, so it is 1 divided by 2 power 5 into 1 divided by 2 power 1 by 5. Okay, so hold on. Okay, so rather than, this is the simplification form, but what do we write it here as? 2 power minus 5 plus minus 1 by 5. So simplify this index, you get 2 power minus 20 minus 26 divided by 5. And how are you going to write it as? 1 divided by 2 power 26 by 5. Okay, so let's take another example. That was a little complicated. So what does, okay, so how about, let's read this first. What does 125 raised to 2 by 3 means? So it is not just about 1 divided by n. What if you are given 125 raised to 2 by 3? What does this mean? It means, how will you write the 3 part? You will write it as cube root of 125, correct? And this 2 part over here, you're going to write it as square. So it means square the cube root of 125. Okay, so how are you going to read this number? Square the cube root of 125. So how about 16 raised to 3 by 4? Cube the fourth root of 16, right? It means cube the fourth root of 16, cube the fourth root of 16. Okay, which is cube root, fourth root of 16 is 2 and 2 cube is 8. Okay, now let's move ahead. So we extend this logic to negative integers and fractions. Okay, first let us consider this for negative integer, that is m will be replaced by minus n. So what do you get? A minus n into a raised to n, which is equals to a n minus n, which is equals to a raised to 0, which is equals to 1. Example, 3 raised to 4 into 3 raised to 5 is 3 raised to 4 plus 5, that is 9. Again, what is 3 raised to minus 5 means? It is 1 divided by 3 raised to 5, which is 1 divided by 243. Let's see example number 1. Simplify this equation if x is 4. So let's directly substitute x. 2 into 4 raised to half into 3 into 4 raised to minus 1. Let us directly shift this constant 3 into 2 6 into and add this 4 raised to half minus 1. Okay, so what do you get? 6 into 4 raised to minus 1 by 2. Okay, what does this mean? 6 divided by square root of 4. So 6 divided by 2, which is 3. I hope you understood this. It is very simple. You just have to substitute. If you didn't understand, please write it in the comment section so that I will take it in the next part of this video. Example 2, simplify. Okay, simplify this equation. What do we get? Hold on. Okay. 6ab square c cube into 4. So if you have negative powers, we will directly divide it so that it will be easy for us. B square c cube and here into d. So b square c cube. So we have 6 4s are 24a d. It is very simple. Let's check the answer. Correct. Law 2 I have already taught you. What is it? A power m divided by a power n is equals to a power m minus n. Okay. So here it is given that m and n are positive integers where m is greater than n. Okay. So let us check with equations and with numbers. So what is a power 3 divided by a power 2? It is a power 3 minus 2, which is equals to a power 1 equals to a. Okay. What if m and n are positive integers but m is less than n? Let's see. A power 2 divided by a power 3. What do you get? A power minus 1. 2 minus 3, which is equals to 1 by a. It is still valid. Okay. So what if m is a negative integer? This is negative. M is negative. Okay. And n is positive. Let's take an example. A power minus 3. Okay. And a power 2. What do we get? A power minus 3 minus 2, which is equal to a power minus 5, which is equals to 1 divided by a power 5, which is still true. Okay, so we can use this as well. So what if m is negative and n is positive? Again, with different numbers, smaller numbers, a power minus 2 and a power 3. You get a power minus 2 minus 3, same, a power minus 5. 1 divided by a power 5. What if, okay, what if m is a positive integer and n is negative now? Example, a power 3 divided by a power minus 2. What do we get? A 3 minus minus 2. Multiplication of two negatives is positive. Multiplication of two positives is positive, and multiplication of one positive, one negative is negative. So what do you get? A 3 plus 2, which is 5. A power 5, which is still true. What if m is positive and n is negative with different numbers? Again, a power 2 and a power minus 3. What do you get? A power 2 minus minus 3, which is equals to a power 5. Okay, still valid, right? What if m is a negative integer and n is also a negative integer? Both are negatives and m is greater than n. Let's take an example. A power minus 2 divided by a power minus 3. So minus 2 is greater than minus 3. What do you get? A power minus 2 minus minus 3, which is equals to a power minus, sorry, a power 1 plus 1, which is equals to a. Okay, this is also right. Now what if both are negative integers and m is smaller than n? A power minus 3 and divided by a power minus 2. What do you get? A power minus 3 minus minus 2, which is equals to a power minus 1, which is equals to 1 divided by a. Still true. Okay, let's see. Now we take some numerical, okay, and check the validity of this law. So I have already taught you the validity. Suppose 2 power 7 divided by 2 power 4. So you are going to, in the numerator, 2 7 times, and in the denominator 2 4 times. You're going to cut 4 times from numerator as well, and you are left with only 3 times. Okay, 2 multiplied 3 times, correct? So which is 2 power 3, which is equals to 8. Okay, so there is another proof as well. Let's see example 3, which is very simple. Let's simplify and find the value of this. So 4 into x power 1 is, let's just directly write, okay, 4 into 1x divided by 1 divided by x power 1/3. Okay, so this is going to flip. Oh, okay, hold on. 4 into 1 by x whole divided by 1 x 1 divided by x raised to 1 by 3. This is going to flip. We get 4 by x into x 1/3. So this, or maybe if you don't write minus 1, hold on. Okay, let's just directly take this denominator to the numerator. Let's not complicate. So what do you get? 4 into x minus 1 minus minus 1 by 3. So 4x minus 1 plus 1 by 3, and 4x to third minus 2 third, which is 4 divided by x raised to 2 by 3. Example 4. Let us simplify this, and the value of a is already given. Okay. Okay, so to into a is 4, right? So square root of 4 is 2 again. Okay. And what do you have? Hold on. 2 into 4, 1 by 2 plus 2 by 3, 2. Let's take all the constants to the left hand side. 2 into 6. Hold on, just a minute.